Welcome to our atomic physics lecture, and today we'll be looking at nuclear energy. Now, Albert Einstein states that when a nuclear reaction takes place and there is a reduction in mass, energy will be produced, while if energy is needed for the reaction to occur, mass will be produced. What this basically means is this: if you have a reactant that weighs 10 kilograms, right? And then you have a product that weighs 2 kilograms. What happened to the other 8? And what he's basically saying is that 8 kilogram was converted into energy. Now, the difference in mass of the reactants and the product is known as the mass equivalent or the mass defect. And it will determine the energy produced or used up in the reaction. Now, the famous equation is E is equal to mc squared. And in this equation, m is the mass equivalent and c is the speed of light, which is 3 times 10 to the 8th meters per second. Now, when we're looking at nuclear reactions, there are two main types: nuclear fusion and nuclear fission. Now, when it comes to nuclear fission occurs when a heavy nucleus breaks down into lighter forms. So with nuclear fission, you have a heavy nucleus and it breaks down into a lighter form, meaning it breaks apart. And when it comes to nuclear fusion occurs when the light nuclei of both nuclei interact and they combine to form a much larger nucleus. So we're going to attempt a question. Now, these questions are not as hard as they come. Now, when it comes on to nuclear reactions, we can get questions that are similar to this. Now, I'm sure you're familiar with this U, and U is known as the unified mass unit, which is 1.6 times 10 to the minus 27 kilograms. That's what this U means. So basically, this 4.004 is being multiplied by this value. Now we're going to attempt the question. So the rule of thumb with these questions is that reactants minus products. That's how we work these questions. Now, this would be our reactant. And here would be our product. Now, when we get a question like this, we use the different masses that are given in the question. Now, the reactant here is PO. So it's going to be 209.982 minus, and we have two products here, one being lead, and lead as given as plus, because it's two products, helium, which was given as 4.004, and this is all being multiplied by U. Now, when we work this out, we're going to end up with, and when we add these values together, we're going to end up with 209.973 U, and the final answer will be 0.009 U. So we minus the reactant and the product. So it's reactant minus product. And with that, we use the masses that were given. And we know there are two products and the product masses. And we work to find this value. Now, this value we're going to use to find the energy that was emitted. Now, with that said, remember when we mentioned that the U symbolizes 1.66 times 10 to the minus 27 kilograms. Now we have 0.009 and we're going to multiply it by 1.66 times 10 to the minus 27 because we want to convert this value into kilograms. So we know how much mass was lost by the system, giving us 1.49 times 10 to the minus 29 kilograms. So this is the amount of mass that was lost. So mass lost. Now, since we know the mass loss, we can actually use the E equal mc squared equation to find the energy loss, because now the basis of this equation is that energy is equal to mass. That's the basis of this equation. So E then is equal to 1.49 times 10 to the minus 29 kilograms multiplied by the speed of light squared, giving us a final value of 1.34 times 10 to the minus 12 joules. And this is the energy emitted.